Okay, let's dive into this. Welcome to today's Explainer. We're about to unlock some serious AI superpowers together. Because whether you're a beginner script kiddie just starting out, or a seasoned software engineer, large language models, or LLMs, are completely changing the game. We are way past using AI as just a glorified search engine. We're talking about utilizing AI as a highly capable, always-on copilot that can fundamentally transform exactly how we work.
To guide our learning today, this explainer is going to follow a leveling up progression. We'll start off with level 1, meeting your AI copilot. Then we'll scale up through debugging and optimizing code, translating and refactoring, simulating entire servers and systems. And finally, we'll hit boss level, automating those super tedious unit tests.
All right, level 1, meet your AI copilot. Let's focus on the concept of role-play framing.
So what is role-play framing? Well, it's exactly what it sounds like. We explicitly tell the AI to take on a very specific persona before we even ask it to solve a problem. Notice how this prompt starts, act as a junior Python programmer. By giving the AI that clear instruction right out of the gate, we're priming it to generate an immediate, highly targeted script. Then we just feed it our precise constraints. 3 arrays, 6 items each, specifically asking for prepositions, verbs, and nouns. And man, it absolutely nails it. It imports the random module, sets up the exact lists we asked for, and uses a clean F string to output a fully functional Python madlib script. It's clean, it's readable, and best of all, it works straight out of the box, all because the request was framed perfectly.
But here's the thing. Python? That's just the tip of the iceberg. The sheer breadth of programming languages these modern LLMs understand is overwhelming, but in the best way possible. We aren't just talking about your recent favorites like Rust or Go, or even bleeding-edge languages like Zig and Kotlin. The AI is a complete polyglot. It is equally fluent in ancient dialects. It can write in assembly, Fortran, Lisp, and COBOL. It sets an incredible stage for what's actually possible here.
Which brings us to level 2, debugging and optimizing code. This is where we focus on fixing logic and drastically improving speed. Because, let's be real, generating code from scratch is great, but developers spend so many hours on maintenance, right? Hunting down weird logical errors and trying to speed up incredibly clunky scripts. Take a standard, inefficient, brute force nested loop script designed to find prime numbers. Sure, it works, but it's painfully slow. But if we feed that code to the AI and say, act like a very senior Python developer, please optimize this script, well, this brilliantly illustrates the power of AI. It completely rewrites the logic, swapping out that slow loop for the sleek, highly optimized sieve of Aristotle's algorithm, instantly. So the crucial takeaway here is that AI can fix syntax and optimize logic within a single script effortlessly. But that naturally raises a much bigger question. What if your problem is bigger? What if you need an AI to evaluate multiple files across different directories? Or what if you're tasked with entirely modernizing an outdated code base?
Let's level up again. Section 3, translating and refactoring. It's all about acting as a bridge between the past and the present.
And once again, we're leaning heavily on the power of role-play framing. Check out this prompt. Act like an experienced developer with knowledge of both COBOL and Python. Think about that for a second. We are literally tasking the AI to bridge 2 completely different eras of software development. We then hand it a legacy COBOL program that calculates Social Security tax and ask for a modern Python equivalent. The results, they're night and day. You've got this dense, highly structured, all-caps COBOL code with its identification division and all that legacy baggage. And then the AI hands back a concise, 3-line Python script that does the exact same calculation. It seamlessly translates a clunky, decades-old tax calculation into a sleek, modern script, proving its immense value for modernizing legacy systems.
All right, buckle up because we are about to enter the most advanced section of this explainer. If an AI understands code so deeply that it can translate logic across decades of syntax, can it actually run a command line? Could it actually simulate a whole server environment without any real hardware behind it? Let's move to section 4 and see how this builds, simulating servers and systems.
This is where things get truly mind-bending. You can actually walk through a sequential build of a simulated Microsoft SQL Server environment using nothing but conversational prompts. Seriously. You tell the AI to act as Microsoft SQL Server. Then, you ask it to create a politics database. Next, create a politicians table. Have it add columns for name, country, and lifespan. and fill it with historical data. Finally, ask it to alter the table to add a second-in-command column. The AI will literally spit back perfectly formatted transact SQL commands as if you were truly querying a live database.
So how on earth is it doing this? Well, it all comes down to something called the context window. This is simply the amount of text or data an AI can remember and process during a single conversational session. It's the absolute secret sauce here. This is the crucial feature that allows the AI to temporarily remember your directory changes in a simulated Linux shell or remember the exact structure of that virtual SQL database you just built. It's essentially acting as a temporary virtual machine hosted entirely within the AI's working memory.
And we can totally take advantage of this context window by shifting the roleplay yet again. Let's cast the AI as an Apache web server this time. We just pass it some standard browser request headers, like a simple get/example http/1.1, and we ask, how would you respond?
The AI outputs perfect HTTP response headers, just like a real live Apache server running on an Ubuntu machine would. You get the 200 OK status, the exact server details, the content type. It is flawlessly hallucinating a perfectly valid server response. Now, what's really interesting about this capability is the staggering variety of network protocols and APIs the AI can emulate straight out of the box. I mean, we're talking very old protocols like Telnet, FTP, and SMTP, moving through more recent RESTful and SOAP APIs, all the way up to bleeding-edge container management like Kubernetes, Docker, and Istio APIs. If you ever need to test how your code interacts with a specific protocol, you can just ask your AI Copilot to emulate that endpoint for you instantly. It's a total game changer.
Okay, moving on to our final level. Section 5, automating tedious unit tests.
Let's be honest, writing unit tests is arguably one of the most universally disliked tasks in a developer's workflow, right? It's absolutely crucial, sure, but it is incredibly tedious. But check this out. By using this prompt, act as a Python software test engineer, and feeding the AI that tax estimator program we translated earlier, we are effectively delegating the entire process of creating edge case tests. This simple act of delegation, it can save you countless hours of mind-numbing work.
The AI gives you back a comprehensive suite of unit tests built perfectly for Python's standard unit test framework. Without you having to type out a single line of logic yourself, the AI automatically generates robust tests covering low-income, mid-income, and high-income scenarios, both with and without expenses. It literally anticipates the edge cases for you.
Which leaves us with this final, provocative thought to wrap up our explainer today. Think about it. If you master these techniques, your AI is now acting as your junior developer writing all your boilerplate. It's your debugger fixing your logical errors, and it's your dedicated testing engineer handling all those annoying edge cases. So, what higher-level problems will you finally have the time to solve? You are no longer just a manual coder. By leveraging the structured prompts and concepts we've explored today, you have leveled up into a powerful AI orchestrator. Thank you so much for joining me on this explainer, and hey, happy coding!